Hi guys, Shouvik here. Welcome back to our channel. So today we will solve another question from Leetcode itself. So let's get started. Yes. So today we have the count the hidden sequences. So on that problem statement, they have given to us a zero index integer array of n integers differences, which describes the differences between each pair of consecutive integers of hidden sequence of length n plus 1. Right. So more formally, call hidden sequence of hidden. Then we have that differences of I is equals to hidden I plus 1 minus hidden, right? So it is like quite simple. Like if I can quickly describe you to just a quick one note. So let's suppose you have a sequence, you have a hidden sequence. Let's suppose you it happens. Let's suppose you have a hidden sequence, and it is A, B, C, D. So now what they have given us differences sequence. A differences sequence, how you can define it? It can be defined by difference of two consecutive elements. So B minus A they have given, then C minus B they have given, then D minus C they have given, right? So these things they have given. So this what they have given? They have given this differences sequence. So these things they have given. Now let's move to the problem statement again. They have also given further given two integers lower and upper that describes the inclusive range of the values lower and upper that the hidden sequence can contain. Now they have given another constant. Now the hidden sequence that we assumes can be A, B, C, D. Now for every elements A, B, C, D, everyone should be under the boundary of lower and upper. So these conditions also should be valid, the hidden sequence that we are formulating, right? So these things they have given us the differences array and the lower and upper. Now for example, this differences array lower 1 upper 6, the hidden sequences is a sequence of length 4, because if differences is 3, the hidden sequence is n plus 1. Very straightforward. Whose elements are in between 1 to 6. Now hidden sequence also have the elements of 1 to 6. Now there are two possible hidden sequences. One you can see this, and another one you can see this. But this is not possible since it's contain an elements which is greater than 6. So here you can see this 7 is greater than 6. So it is invalid. And here you can see it is not possible since the differences are not correct. So here you can create the differences array which should not be of 1 minus 3 4. So that's the reason it is also invalid. So now what we have to return the number of possible hidden sequences there are. If there are no possible hidden sequences, then return 0. So the question is, I think, very straightforward. So we don't have to return any hidden sequence. We have to return the count of the hidden sequences that can be formulated. With the given constant they have. So now, what actually this differences array. So now let's think about quickly. Now we can see the constant also. So here you can see the constant is kind of 10 raised to the power 5. So your solution kind of like big of n log n should be fine, or n should be fine. N square is not going to be accepted. And the differences is minus 10 raised to the power 5 to plus 10 raised to the power 5, and lower and upper also in this range, right? Now we can go to the intuitions building, right? So tell me one thing. As we have a limitations, as we have a like constant of there should be a upper, and there should be some lower, there should be some upper, and there should be some lower. Now every elements should lie inside this boundary, and now let's suppose we have something like this. Minus 2 like this way, something like this. So on our differences array, so that means we are keep on gradually decreasing. It's correct, right? So let's suppose I am starting from 4, then my next elements is going to be 2, because 2 minus 4 is minus 2. Then the next elements is going to be 0. Then the next elements is going to be minus 2, right? This satisfied by this satisfied by this satisfied by this, and the last one is going to be satisfied by minus 4. So you can see my elements in the hidden array, is keep on going decreasing if we have consecutive negatives. Similarly, if we have, let's suppose 5, 5, so something like this. So on this case also, I guess it's very intuitive. It can grow, keep on minus 4, minus 4 plus 5, it is 1, then 6, then 11. Like this way it is keep on increasing. So we have some things, we have some things we can see in our hidden array, the maximum dip can be, what is the maximum dip we have achieved? That is of minus 4. If we start from 4, but very generically, let's start from some identity elements. So as we have positive and negative, so which of the elements is not considered as a positive and negative? It is 0. So 0 should be on this case is our identity elements, because it is not relying to positive also, not on the favor of negative also. So we can start our start elements from 0. So if we start from 0, so we are going to minus 2. If we start from 0, minus 2, minus 4, minus 6, minus 8, like this way, we are keep on decreasing. So in our hidden array, right? In our hidden array, we are keep on decreasing. So let's do this. So let's suppose we are starting with some level 0, which is identity elements, and we are doing a, how we can find the maximum depth. It is nothing but the prefix sum of those, or running sum, anything fine. You can say it's prefix sum or running sum. And running sum we are starting with 0. Because 0 is our identity element. So we are starting our running sum for this particular value, and let's suppose we, like this way, we have, let's suppose, increase, and we are going to decrease, and let's suppose at a particular point we went in our lower also, went to our lower also, and let's suppose after that we are going to increase, keep on increasing, and we are going to get to our upper also, right? Let's first focus on our lower. First set our lower. So from 0, starting from the identity elements, which is 0, starting from the identity elements to 0, we are not able to lie. Every elements are not able to lie to within our lower boundary. So we need to start some upper position such that this dip can move from here. So this can go something up, and it can dip from the lower. It's not going to dip more than lower. It should dip at least from lower. So we can start from this level 0 to for sure. So sum up positions, right? So this gap. So let's suppose this is our mean start. This point. So now mathematically, let's try to derive this. So our mean start should be from some point which we are not know, which is still not know, but with this plus minimum of my running sum. I will keep on like adding values to my running sum. But what is the minimum of my running sum? If I can store this value to some mini variables, what is the minimum of my running sum? So the formula should be something like this: my mean start, which is still not know, right? Plus some mini. So that is, mini is nothing but the minimum of my running sum should be greater than whom? My lower. Should be greater than my lower. Agree guys? Definitely. So then my mean start, which we are trying to define, is nothing. So this mean start should be my greater than my lower minus mini. This formula should satisfy. Agree guys? Agree? I guess you guys are agree, right? Simple mathematics, which we just see in the formula. My mean start plus the dip. So this dip is nothing but the mini. This dip is nothing but my mini, which is considered as identity elements. How far we are able to dip? So with identity elements as 0, we are going to dip with some value which are more smaller than my lower. So we have trying to define a mean start with which if we dip to my mini, our mini, then also we are going to go back from this point. We are not going to go more than my lower. So the formula should be my mean start plus my mini should be greater than my lower. So my mean start should be lower minus mini, right? So I have defined what is the very starting point. What is the very starting point? So maybe let's consider that is as a mean start. That is as a mean start. Now similarly guys, tell me, you should be able to answer what is my mean end. What is my mean end? What is my mean end? So you have defined your mean start from here. Similarly, considering my 0 as a identity elements, we are going to go as up. So let's suppose that is my maxi, considering 0 as my identity elements. So which is invalid because we are crossing our upper. So that's the reason it is invalid. So we should be start. So our mean end should be at some point. To which if we go to deep and when we are hit our maxi, we are not crossing the upper. Exact same logic of what we did for lower. So tell me the formula guys. So we have some mean end plus maxi. Considering 0 as an identity, we don't know what is the mean end. But with the maxi, considering 0 as an identity, what is the maxi we have computed? It should be less than my upper. So the mean end formula is upper minus maxi. Agree guys? Exactly. So my mean end formula is upper minus maxi. So that means if I draw the diagrams correctly now again, so we have some upper, we have some lower, right? And we define a mean start. So with this, everyone should be go just hitting my lower, not going to below of my lower. The maximum dip, just going to hit to the lower, and maybe it's bound to hit. It's bound to go from not hitting the upper. And we have some. So that is my mean start. And we have some mean end. Starting from mean end, we are definitely not going to hit my lower, and we are hitting our upper, but not crossing the upper. We are just hitting my upper, and we are going down. So we have two things: mean start and mean end fixed. So how many sequences then we can form? How many hidden sequences we can form? This gap. So till this, all are valid. So let's suppose I consider my mean start as 2 and mean end as 3. How many then good hidden sequence we can build? 2 and 3. The count is then 2. So it is nothing but my mean end minus mean start plus 1. Mean end minus mean start. So that many gaps we can find. Mean end minus mean start plus 1. As simple as that, guys. It is very, very, very just mathematics. I have done exactly what can I say? Like a peak and trough kind of things, and I am able to define my formula. And what is the gap 0 case? So on the problems they have asked for a 0 case also, right? If there are no possible sequences, then return 0. Now when there is no possible sequence, so tell me, you should be able to answer this. If at any particular points, if my mean start is going to be start from here, right, and my mean end is below, so if I can draw the diagram, I have some upper, I have some lower, and I have some mean start, and let's suppose I have a mean end here. So that means my start and end are cross each other. So mean start is stating that you within, if you want to stay within my lower boundary, then you have to go start from at least here. Otherwise you are going to cross the lower. You are going to get more than the lower deep, and you have some max end which is stating you have to be start at least from here. Otherwise you are going to cross the upper end. Upper boundary, right? Agree guys? So is it a contradiction? So that means starting from this, we have to make our upper, like starting from mean end. If we are starting from this mean end, then we are sure we are within the lower boundary. But as the mean start, we are starting more than my mean end. So mean end is making sure that if you are starting from mean end, then you are within upper. But as mean start is more than your upper, so lower is satisfied, but upper you are going to violate because you are starting above of mean end. So this conditions is violated. And similarly, this dip, as you are starting from some upper positions, then you are able to satisfy. But now you are starting your mean end from here, so you are definitely going to more than the lower. So both the conditions are going to be violated. If our mean start and mean end are cross each other. Exactly same code we have to write. Now go to the code iterations. Nothing on the code. Exact mathematics I have what I have written on the OneNote. Exact same things I have done on my pen and paper, and I have get an easy. So I have initialized my mini and maxi as I already told we need it, and I have assigned my mini to whatever the maximum value can be possible. It can be 10 raised to the power 5. So I have assigned 10 raised to the 5 plus 1, and maxi to be minus 10 raised to the power 5 plus 1 reverse. And I have start my running sum to 0, and I have done exact same things. For each in differences, mini is equals to mean of mini and running sum, max is equals to max of maxi and running sum. Running sum is going to be add to the each because we are doing the running sum or prefix sum. And as we are updating our mini and maxi to the loop first execution, so after running some updations also, maybe we are left with some value. So that we are updating outside the loop. So our mini is going to be mean of mini and running sum, max of maxi and running sum. Now, what is the mean start formula? Lower minus mini. Agree guys? What is the formula of my mean start? Lower minus mini. What is the formula for mean end? Upper minus maxi. Mean start formula is lower minus mini. Mean end formula is upper minus maxi. So now the edge case. If at any particular points, if my mean start is more than my mean end, return 0. Don't have to do anything. Contradictions already you have violated. The current structure already violates the principle. Return 0. Otherwise, your gap could be mean end minus mean start plus 1. Finally, we are returning the gap. The question is guys as simple as that. You just have to write the one. You just have to play with some your pen and paper, and you are able to identify these formulas. So this formula is actually the gems. So that how we have defined just 2 lines of pen and paper works. The question is as simple as that, guys. Now quickly discuss the time complexity and space complexity. So time complexity, we are doing nothing. We are only iterating to a single for loop. It is obviously going to be take off big often. And on space perspective, do you feel guys we are using any extra space? No, all are variables, right? Mini, maxi, running sum, mini, maxi, mean start, main, and everyone is variable. So we can definitely write a constant space we are using. So time complexity is big of n and space complexity is big of 1. So this is bound to be a most optimal solutions for this particular question, and my submission is 100% faster than all the submissions over the Leetcode. So which is bound to happen. So that's it guys, that's it for this particular video. And if you guys are able to understand till this point, so what are you waiting guys? Please do subscribe to our channel, and please share the videos also who are also preparing for top product based company, and also who are also brushing up their DSS skills. So please share the videos to your friend circle so that also they can get the most of it. And please turn on the notification so that when we are going to be live to our next video, you are going to get the notification as soon as possible. And that's it guys, that's it for today. Let's meet tomorrow with another beautiful question. Bye guys, bye.